So this is section 4-3. I think I'm going to use white paper because it's harder to see triangles like that. So this is section 4-3 part, just the first part we're going to talk about today. And this is on right triangle trig, basically. And right triangle trig takes place in the first quadrant. So we're in the first. We're talking about angles in the first quadrant. So all angles in this case are positive, and all sines and cosines are positive, which makes things kind of nice. And then, so if you have a right triangle, let's see if I can make a right triangle. Right triangle. Then I don't like going that way. Now it's over there. We can move it. There you go. So here's a right triangle. And if you're talking about a right triangle, this is angle theta. This is your 90-degree angle. And the sides and theta are related by SOHCAHTOA. Do you remember SOHCAHTOA? How many of you have never seen that before? Okay. And okay, so that stands for sine is equal to the opposite side, the ratio. Sine of theta, I should write. Sine of theta is equal to the ratio of the opposite over the adjacent. Cosine is equal to the ratio of the adjacent over the opposite over adjacent? Opposite over hypotenuse. Sorry. Adjacent over hypotenuse. And tangent is equal to the ratio of the opposite over the adjacent, right? SOHCAHTOA. And so if you're standing here, here's the opposite side, here's the hypotenuse, and the adjacent is the one that's not the opposite side and not the hypotenuse. Okay? So if they do something like this, say they tell you that this is 5 and this is 12, and they say find these 6 trig functions, could you do that? Find the ratio of the 6 trig functions. Yeah. So sine is, so what would I have to do first? And this is a Pythagorean triple. Anyone know what this side comes out to be? Going 13, right? So this one comes up a lot. You should memorize like 5, 12, 13, and 3, 4, 5 because those come up a lot. Okay? We're in math class. So, Bobby, you were. Okay. So anyway, so sine of theta would be 12 over 13. Who can tell me what cotangent of theta would be? Cotangent. What would cotangent of theta be?
5 over 12.
5 over 12. Okay, and so on. So I'm not going to go through all 6. I think you guys can figure that out, right? Then we have the idea of, well, they'll also say, find, so these are not unit circle triangles, meaning the radius is not 1. So you can solve for sides that when this side is not 1. But the ratios of the opposite to the adjacent, they would still be the same. If they say give exact values, I think I talked about this yesterday, but if they say find the exact value of tan of 30, that means that you can use your unit circle. What's tan of 30 equal to? How many radians? Pi over 6. Anyone know what offhand what the tangent of 30 is? Very good. Okay. Allie, right? Yeah. That's equal to root of 3 over 3. And if you didn't remember that, you look at your unit circle. Whoops, that's not a circle, is it? You look at your unit circle, but you'll get better at this as you go along. And it's a lot easier if you memorize these things and you could go kind of fast. But if I were to want to find that, here's pi over 3 on your unit circle, right? Here's 1/2 comma root of 3 over 2. So you would put the opposite side over the, whoops, that's wrong. Root of 3 over 2 comma 1/2, right? Root of 3, what am I? Pi over 6. And that's root of 3 over 2 comma 1/2. So if I put this over this, I get 1/2 divided by square root of 3 over 2, which is the same as multiplying by the reciprocal, 2 over root of 3, and those cancel out, and you get 1 over root of 3, and if you rationalize the denominator, you get root of 3 over 3. But another thing, you might want to just commit to your memory. Tangent of 30 is root of 3 over 3. Tangent of 60, you know what that is? It's just plain old root of 3, okay? And then so cotangent and tangent, since they're cofunctions, they flip-flop. So the cotangent of pi over 6 would be root of 3, and the cotangent of pi over 3, which is 60 degrees, would be root of 3 over 3. So it's just kind of nice to, so tangent at the 30s and the 60s is either always going to be root of 3 or root of 3 over 3. And if you kind of can memorize one of them, then you could memorize the other 3 real quickly. If you just know that tangent of pi over 6 is root of 3 over 3, cotangent's got to be root of 3, right? And then you go to 60 and they flip, right? So all you really have to remember is one thing, okay? Cofunctions. So we talked about reciprocal functions. These are a little bit different than cofunctions. Cofunctions, they kind of go functions. So you have sine of theta and cosine of theta are cofunctions. Secant of theta and cosecant of theta are cofunctions, and tangent of theta and cotangent of theta are cofunctions. Does anyone know why they're called cofunctions? Because if this is, it's kind of like what I was telling you with the tangent and cotangent. The tangent of 30 degrees is, what would be the tangent of 30? Tangent 30? I just told you. Root of 3 over 3. What's the cotangent of 60? Root of 3 over 3. That's why they're called cofunctions, okay? Because the tangent of one of the functions is equal to the co-function of 90 minus that function, okay? So sine of theta is equal to the cosine of 90 minus theta. And secant of theta is equal to cosecant of 90 minus theta, okay? And tangent of theta is equal to the cotangent of 90 minus theta. So if I know, for instance, that the cosine of pi over 6 is equal to, who knows what the cosine of pi over 6 is? Look at your unit circle. Look at your, where's your radian man? Root of 3 over 2, okay? That means that the sine of pi over, what's the cofunction of pi over 6? Pi over 6 is 30 degrees. What's the cofunction of pi? What's the co-angle of pi over 6? What's 90 minus, or pi over 2 minus pi over 6? 30, 90 minus 30? 60. What's 60 in radians? Pi over 3. So what's the sine of pi over 3? What's the sine of pi over 3? Also root of 3 over 2, right? So if you subtract, so the cofunction is the 90 minus the whatever angle you're talking about is going to give you the same value. Okay, so cosine of pi over 6 is the same as sine of pi over 3. Tangent of I don't know, 75 is the same as the cotangent, if I'm in degrees, is the same as the cotangent of, the cotangent of what? 15 degrees. So you just subtract from 90 and you get it. All right? Okay. Now I'm going to do one kind of tricky word problem, and then I'll let you, well, let's just do one easy word problem, and then we'll do this. Okay, so I'm going to draw a triangle. Michaela, wake up. All right, so here we go. Here's a triangle. You want to tell me how to solve this triangle, Michaela? How would I find y and x? And this is 60 and this is 12. Okay, so set up the equation for me.
Okay, so sine of 60
Sine of 60
equals x over 12.
equals x over 12. And so what's x equal to? How do I get rid of this 12 down here?
Multiply out.
Right, 12 times the sine of 60. You can find this exactly. Okay, if they say exact, what's the sine of 60? Root of 3 over 2. Okay, so this is 12 times root of 3 over 2. So if they ask for an exact answer, this is equal to 6 root of 3. So this over here is 6 root of 3. Okay. What's this over here going to be? You could do this because this is a 30, 60, 90. Oh, that doesn't look like 30, does it? What would this side be based on what you know about 30, 60, 90s? What's that side? No calculators. What's that side? 30, 60, 90. Go ahead, Sam. What's the relationship between the side opposite of 30 and the hypotenuse? Half, right? So this is half of 12, which is 6. Or you could have said that the cosine of 60 is equal to adjacent. It's equal to 6. It's not. I don't know. It's 6. Is equal to x over 12. I know that the cosine of 60 is 1/2 equals x over 12, and then I cross multiply, and I get x equals 6. Or I can use my relationship for special right triangles. Yes, Sally?
Can you write the rules for 30, 60, 90?
30, 60, 90. This is 30, 60, 90. Sure. 30, 60, 90. If this is 30, and this is 60, and this is x, then this is 1/2 x. And this is root of 3 over 2x. Okay? And 45, 45, 90. It's, if this is 45 special right triangle, whoa. I make it, look at that. I'm good. So if this is x, this is going to be x root of 2 over 2. And this is going to be x root of 2 over 2. Or you can multiply this side by root of 2 to get that side. But that's something that you could have learned in geometry. One more problem. Boo! Didn't work. Okay. Okay. It's okay. He's got a night shift somewhere. So, there we go. So, well, that's not what I wanted to draw. Let me try that again. So say I have a homework problem like this, and I like homework problems like this because they're a little more interesting than just SOHCAHTOA problems. And say you know this is 50 feet, and say you know that this is angle is 25 degrees, and say you know that this angle is 40 degrees, and there's some building sitting over here, something like that. Here's the building, okay? And you want to save, you're the fireman, and you want to save the drowning person, or or not the drowning, the person who's on fire, okay? Who can, how would you do that? How would you do that? If you wanted to find H over here. First you have to find X, and then you have to find H, okay? So how would I find X?
25 over 50 equals 40 over X.
25 over 50. 25 over 50. No, you can't. They're not similar triangles. You can't do that. And you can't do it with angles and sides. So I think first what you would have to do, I think with this one, see, so you need two things, right? And you don't know, all you know is that this is 50 feet from here to here, right? And you know that that piece we're going to call X. So you kind of have to set up two equations with two unknowns. Go ahead, Zach.
So first would you have to find 140 minus 80 to find the angle next to 25?
140.
No, 40 minus 180.
40 minus 180
Because
to
then-
find, very good.
And then with those two numbers, you can find the angle up there.
Yeah. And then you could use a lot of signs, right? But we don't know a lot of signs yet. So what if I were just trying to do it using, that's fine, you know, but what if I were just trying to do it with right triangle trig? Who could give me an equation involving this triangle right here? What could I do with that triangle with H and X?
Sine of 40.
How about tan of 40? Tan of 40 is equal to what? H over X. And I also know that the tangent of 25 is equal to what over what? H over 50 plus X, right? 50 plus X. Now this problem can be algebraically a little bit tricky, so I think you should watch. You should watch. Hey.
I'm good.
No, you need to open your eyes. Okay. Okay. So I cross multiply. I get x tan 40. X tan 40 equals h. See what I did? Cross multiply. And then I have to go 50 plus x times the tangent of 25 is also equal to h. Then what could I do with those two equations? I can substitute them in for each other, or I can set them equal. So now I could write that x tan 40 equals 50 plus x, 50 degrees, right? No, 50 feet, sorry. 50 plus x times the tangent of 25, and that's in degrees as well. And then this problem becomes a little bit messy because you have to distribute through this, and you get x tan 40, and then you distribute this through, and you get 50 tan 25, which comes out to be a number, is equal to x tan 25, which comes out to be another decimal number. And then you get all your x's together and stuff, and then you solve x. Could you finish the rest of the problem? Just don't forget that you got to distribute this through. Could I solve it for you? Yeah, I could. But
Mr. Leader, can you show us law of sines and cosines? Since we did go over that last time.
I know, but I think that comes later on, okay? And so we're not going to, you want me to finish it? Okay. X tan of 40. So now we're going to be in, I'm going to get my calculator, okay? And here we go. And for this type of problem, you got to make sure you're in degree mode. Okay? So go. And so I'm going to go to mode. I think I was in radians before. Oh, I'm in degree mode now. I'm going to second quit. And so tan of 40 equals 0.839. And you want to take this to several decimal places, right? So probably to 4 decimal places. So I'm going to say that solving this problem, okay, I'm going to get what did I say that was? 0.8391, I think, x, right, because that's what tan of 40 is equal to 50 tan 25. I guess we have to figure out what 50 tan 25 is. 50 times tan 25. Whoops, not 255. 50 tan 25. And you get 23.315 equals 23.315, and then 50 times, and then plus x tan 25.
But Mr. Lita?
Yes?
Why would we add 50 plus 10, 25? Does that say plus or?
50 plus. No, this is plus. Because we.
Multiply it times 10. Oh, okay.
And then I have to multiply x times tan of 25. 25 equals 0.4663. So that's 0.4663x, right? Because I have to multiply it, distribute. Okay? Then I can add up bring this x onto that side. So I have 0.8391, 0.8391 minus 0.4663 equals 0.3728x equals 23.315, and then I'm going to divide, right? So 23.315 divided by 0.3728, and I get that building is about, or x is about 62.54. I'm not done yet because I have to find h, right? So when I to find h, I would just take that 0.62.54 and plug it back into here or into here, right? And I would get it. You guys could do that, right?
Yeah.
Okay, so that's how you do that. You could solve it algebraically for x. What I prefer to do is get x by itself and solve it all in one chunk, but sometimes that gets people confused, so I'm not going to do that. All right, so that's it. You could start on your homework, which is somewhere. Here it is. Page 280. 1 through 6. 1 through 6. 8 through 36 evens. And then not too bad today. 73, 76, 80, and 81. 73, 76, 80, and 81. And that's it. And remember, you heard it here on Mr. Leader's Cutting Edge.